structures in this entire era. I'll be taking you through the entire course of centuries and how we have evolved as structural engineers. As humans have found three common materials which have helped us to build our entire civilization. When I talk about civilization, I mean how we have built amphitheaters, how we have built auditoriums, stadiums, residential apartments and commercial buildings. Three common materials that we have found is steel, timber, and later on we went on inventions of concrete. Over the course of time, I have realized that constructing any structure involves a process. The process comprises of design, construction, and then final handover for which the entire structure is being used. In the design stage, this is one of the aspects I have learned during our course of study at IIT Roorkee. This is a bridge which we have made out of 9,000 ice cream sticks. The span of the bridge was about 1 meter and it could take a load of about 250 kgs. So this is a basic process, and the same process is followed for every structure that we build for our civilizations. You can see we standing on the bridge and a load of 250 kgs applied to it. Over the period of time, in ancient centuries, there was a cementitious material which was used for constructing our civilization. As we evolved, as industrialization began, we have discovered and invented cement, which was popularly known as Portland cement. Later on, we went on to add admixtures, sand, aggregate, and so on, which formed concrete. And today, as you all popularly know, we use reinforced cement concrete to build our structures. Let me tell you something about Colosseum. This was a famous structure built in 70 AD by Roman Empire. Today as well, we can see some of the features of this Colosseum, though it has deteriorated and several times it is retrofitted in this century. But just imagine a structure to have been lasting for almost 2,000 number of years. Isn't it amazing? This is purely a load-bearing structure. You can see the thicknesses of the walls. In that particular era, this structure was built by engineers and laborers. The next beautiful structure that we know, Taj Mahal. On the same lines, Taj Mahal was built as a load-bearing structure. Even the foundations of the Taj Mahal was built in load-bearing structures, popularly known as wells and caisson systems. The beautiful calligraphy that was crafted in that particular era is still appreciated by. This structure was a load-bearing structure. On top of it, as you all popularly know, marble cladding was done. These are the various ancillary buildings surrounding the main structure that was built in that particular era. Let me take you across to the structure in 20th century. This is a popularly known as Akashi Kaikyo Bridge built in Japan. The central span is about 2 kilometers. Just imagine a structure beautifully built without any support spanning up to 2 kilometers. This is entirely built in steel structure. The foundations and abutments are built in concrete. They have used high performance concrete. Over the period of time, in 20th century, we evolved and we developed high performance concrete. Over the period of time, we changed our methodologies of construction. Instead of going to the site and pouring the concrete, people started evolving and thinking about prefabricated designs. This was the first such humongous structure known as Habitat 67, built by architect Sabdi. Just imagine each and every room of this particular structure is about 70 to 80 tons. Specialized mechanized cranes were used for lifting each of these modules of the rooms, and that's how this entire structure was built. These are some of the demonstration sketches by them, how they have constructed this entire building. One such next structure which we all know in this 21st century is Burj Al Khalifa. It is one of the standing tall towers which is seen by us. This is beautifully designed in such a way that it allows the wind to easily pass through the structure with reducing the wind effect on this building. This is beautifully designed for earthquake and wind loads. The popular vortice effects of winds are nullified and reduced. Another such technology used for constructing this building is slip formwork. Slip formwork is a formwork system which is mechanized in such a way it moves vertically upwards with the help of hydraulic systems. I'm going to showcase you the next phenomena that we are using in this 21st century. This is called as a 3D volumetric precast construction. In 3D volumetric precast construction, all the rooms are fabricated in the factory and these are assembled on the site like a jigsaw puzzle. Please have a look. Once the foundations are done in cast in situ in normal method, the structure typical floors above are constructed using 3D volumetric precast construction. Across the globe, lot of structures are built using 3D volumetric precast construction. And in India as well, we are tremendously seeing the potential of 3D volumetric construction. A lot of 3D modules of a room size, typically weighing about 12 to 15 tons, are built in the factory with all the finishes such as painting, tiling, everything done in the factory, and then these modules are assembled on the site. As you have seen the Habitat 67 project, in comparison to that, we have drastically reduced the weight of these particular pods, thereby the availability of tower cranes which can easily lift these 15 tons of pods to a vertical limitation of 80 to 90 meters. And thereby, let me tell you the quantum of work which we can do in 1 year. Almost we can build 1 million square feet of project within a period of 1 year with reduced amount of human resources on site. In today's era of robotics, artificial intelligence, data-driven and digitalization, this is the need of an hour today. It also allows us for sustainable development. The wastage of all the construction materials is reduced drastically. You can see this video animation is being done well before the entire development is constructed. This is called as a building information modeling tool that is being used across the design industry in the world. Let me take you across how we are going to build small-scale homes in this 21st century. Now, if you see the automobile industry, you do not approach a mechanical engineer and tell him, okay, I'll pay you something, you please make a car for me. And have you imagined, the mechanical engineer will work on every spare part of the car, sitting on the lathe machine and preparing a small engine tool, everything, steering wheel, tires, everything he'll prepare independently for you, He'll take 2 to 3 years of time and then he will deliver you the car in 3 years. Have you ever seen that? No. Because that evolution of automobile industry has happened in 19th century. The similar evolution is being happening for construction industry today. In later centuries, you will see that you directly have to approach a contractor or a distribution center. You approach him, you tell him that this is my land parcel, I have a piece of land and please construct a home for me. I'll show you the imagination of this idea wherein if you approach a contractor, you will get your house within a span of 30 days. All the house components such as beams, slabs, staircase, landing, mid-landing, everything would be fabricated in the factory. Some of the sample pieces I can show it to you for demo. There are some models which are kept on the table which you can later on visit as well. All these components of the building are fabricated in the factory and then these are assembled on the site. So let's say if you place the order, the factory components are already fabricated and it takes almost about 3 to 4 days to assemble all these components. This design is done in such a way that using 6 variety of components, you can fabricate 500 different configurations of houses. So from this library of 500 houses, you can select one of the house that you like and then the contractor will deliver you the entire house within a span of 30 days. So after 30 days, you will get the keys of the house. It will be a perfectly livable house for you. So whether the aspect ratio of the plots changes, but still, as I have told you, these components are designed for 500 different libraries of homes. So merely, it takes almost about 6 to 7 skilled laborers with an engineering supervisor to complete this entire house. You do not have to deal with several agencies such as plumber, electrician, RCC contractor, finishes contractor and so on to build your modular house. And there are several companies across the world who are working on the same principle in this 21st century to build homes for our civilization. Let me take you through realistic projects which are done in 21st century. This building, what you see here, it's 100 apartment scheme building, 1 lakh square feet. It was delivered in 6 months of time frame. All the components of this building were fabricated in the factory, transported across the road from 450 kilometers, and this building was constructed. The wall panels, the bathrooms were also constructed in the factory. These are the bathroom pods, what you see here, with all the internal finishes done. These are the wall panels. Staircase, landing, mid-landing, everything was fabricated in the factory. These are the finished rooms. Once the completion of the building is done, you will not be able to differentiate between a conventional building and modular or precast buildings. This is a finished building. It was completed in a merely span of 5 months. I'll just show you a quick video of the construction. You can just see the assembly of every building element is being done on site. And you can see the site is being, managed by reduced number of manpower. You just require 5 people for 1 crane to handle the pieces on site. 21st century. This project is based out of India in Bangalore. This is the first public building constructed in Bangalore in precast. Now public buildings have a special appeal, they have special architectural features, and when they are constructed in the factory, you can achieve a lot more precise designs and accuracy in aesthetics. For this project, it was done entirely digitally in BIM, and all the shop drawings and drawings were created out of it, and then using robotic and automations, the components are fabricated in the factory. You can see how the arches and preciseness is achieved. This minaret is about 35 meters tall from the terrace, and it's beautifully done in precast. All the components are brought through trailers and erected on the site. This is the finished structure. Only primer and paint is done. This is the finished structure in the building that you see from the factory directly. Now this amazing home that I'm going to show it to you, it is completed in merely 2.5 hours. Right from the foundations, the grade slab, the wall panels is erected, and this entire home of 500 square feet is erected in a period of 2.5 hours. Even though the finishing time will be approximately 10 days, but a home of such a scale could be handed over to you over a period of 2 weeks. Let me take you to the final stage of 3D printing. As species, we are still evolving over this technology, but this connects us to the Roman Empire. We are coming back to printing the concrete and the load-bearing structures. Right now, as 3D printing is still evolving, it is not capable to print two different materials at the same time. And hence, we are not able to scale it up to high-rise buildings and so on, because we require tensile capacity for a structure to go and resist earthquake and wind loadings. So you can see 3D printing being implemented for several small-scale structures. And this is one of the latest trends which few of the companies across the world are using it to create low-rise structures. Let me end this on a thoughtful note. We need to invest our thoughts today in order to arrive at solutions which are sustainable in nature, and also interestingly we have to think how we build our civilization for our next centuries and civilizations to appreciate our work. So it has to be long-lasting, sustainable future, and we have to create it together. Thank you.